Coagulation is the addition of chemicals to destabilize the electrostatic forces of non-settlable solids. Coagulant chemicals typically have a positive charge, which binds to the negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particles called microfloc. In most cases, the chemical reaction occurs in a fraction of a second, so it's important the coagulant is dispersed quickly and evenly to encourage as many particle collisions as possible. Because this process relies on chemical reactions, several considerations must be made. Water temperature, for example. Colder water usually slows coagulation and flocculation reactions, which may require more time to achieve optimal floc formation. Extreme values of pH, high or low, will also interfere with the process. Coagulant effectiveness is highly dependent on pH. For some coagulants, alkalinity is a factor. Operators may need to raise alkalinity for coagulation to be effective when using iron or aluminum coagulants that can consume alkalinity and depress pH when they are added to low alkalinity waters. Turbidity is also important. The lower the turbidity, the more difficult it is to form proper floc. The most common coagulant chemical used is aluminum sulfate, commonly called alum. When added to water, alum forms jelly-like particles of aluminum hydroxide. The trivalent aluminum ions neutralize and attach to negatively charged particles in water, forming microfloc. Alum works best in a pH range of 5.5 to 7.5. Polyaluminum chloride and iron salts such as ferric chloride and ferric sulfate are also used. They operate over a wider pH range. Coagulant and flocculant aids are added to improve binding, build stronger, more settlable floc, and affect flocculation by increasing floc size, strength, and/or floc density. In addition, they help overcome the effect of low temperatures, reduce the amount of coagulant needed, and reduce the amount of sludge produced. Commonly used coagulant aids include cationic polymers. Polymers are defined as a synthetic compound with high molecular weight and composed of repeating chemical units or monomers. Polymers may be polyelectrolytes, such as the water-soluble flocculants, water-insoluble ion exchange resins, or insoluble uncharged materials. Polymers are long chains of molecules that produce highly charged ions and help bind microfloc together into larger floc particles. They are very popular with operators because they are very effective and can be positive, negative, or neutrally charged, providing a great deal of flexibility in different circumstances.